All right, welcome back. Another video. Guys, I woke up at like 2:30 p.m. today. Oops. Oopsie daisy, you know how it be. Yeah, I got finals next week, but the finals aren't too challenging. It's like I have to get like a 72 to get like an A minus and like a 98 to get an A. So, like I'm not getting a 98, bro. I'm telling you right now. Um, but yeah, just make the Pokemon sound of the day. That Pokemon today is Machamp. So let's just get into it. And guys, just a quick update before I do this. Um, I'm going home for winter break on Wednesday or Thursday. I haven't really decided. And for now, I'm not really gonna work on a I think I'm gonna. You guys, I just been getting real sick of these stupid projects. um, so I'm just gonna do a little bit more like Leetcode and like C++ like learning centric. I have a big project plan for winter break that I want to do. It's gonna be a game. I want to make a game, but it's gonna take me a while. But I don't want to start it until I get home, because that's what I decided. Um, so just yeah, no project for now. Yeah, I'm trying to get through all the learn CPP resources really quickly so that I can move on to other textbooks. But yeah, Pokemon Sound of the Day. Machamp. Alrighty. I think the problem with the day isn't easy, so we might just do that. Take gifts from richest pile on some CPP shit. Oh, okay. All right. Long. All right. How to use a max heap. C++. Um, yeah. So while on for can I just do this? Max heap. Uh, and then how to take SQRT. Okay. How to take Um, can I do that? Oh, it is. There is empty. That empty. Right, it's that top. And pop. Okay. Hmm. Oh, I'm not popping it. Interesting. Interesting. Oh, what the? Oh man, that was tough. That was weirdly tricky. Only took 10 minutes though. All right. Nice. Let's do this hard one, car fleet. In 20, I have like 20 minutes. I have to do laundry. I put it in the thing. Mm-hmm. This is a stack problem? Man, I don't even know how to do this at all. Oh, wait. Why are they in an unsorted order? I think these should probably be sorted, no? 10, 8. So it should be 0, 3. Hmm. I just have no idea how I'm supposed to use a stack. I mean, I don't know how to solve it like without brute forcing. Like if I let's not do this. Let's do like it's you're supposed to draw like a thing. So like and then it's okay, so like this is like position. Wait, I don't think this works the way I'm thinking it's gonna work. How do I draw this linear relationship? Am I stupid? You have to draw like a line. Like this card starts at position 10. Dude, what is the relationship between position and speed? It's like, dude, oh my God, why am I actually like really struggling to graph this? I need some math tutoring. Dude, how do you graph this? Like, what the hell? I'm like, okay, like the one at 0, speed 1. So this should be speed then. Space is out a little bit more. 1, 2, 3, 4. So this first one should just be like this, right? Okay, and then the next one is 3. 1, 0, 1, 2, 3. With a speed of 3. Yeah, because it's 1, 2, 3, so it needs to be right here. And then 5 is the next one. So 0, 1, 2, 3, 4, 5 has a speed of 1. So a linear relationship once more. Oh, and the problem is that this is 1. Yeah. I guess they really be hearing it. All right. I don't know if this line is accurate. 1. Hold on. Yeah, it's not. Okay. I'm gonna redraw this whole thing. I think I know how to do it though. These need to be equal lengths for starters. All right. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh shit. Okay, that's fine. Okay, so 0 has a speed of 1. We already discussed that. So it's gonna be like up here. Can I like hold on. Right there. Okay. So the next one is 3. So 0, 1, 2, 3. And its slope is 3. So it needs to go 3. So 1, 2, 3, and over 1. 1, 2, 3, and over 1. Okay. And then the next one is, we need to label it 3. And then what's next? 5. 0, 1, 2, 3, 4, 5. With the slope of 1. Very simple. So 1, 2, 3, 4, 5. Now we got 8. 0, 1, 2, 6, 7. With a slope of 4. Interesting. 1, 2, 3, 4 over 1. And then ten, which is right here. And then that has a speed of 2. So 1, 2. So yeah, so this graph, 1, 2, 3. I just realized this didn't help me at all. I don't really know what I'm looking at. I swear, man, it's always draw a diagram, draw a diagram. I draw the diagram, and then I have no idea what I'm looking at. Because, like, what if this intersection happened, like, somewhere else? Is it like... I don't know what it's like. I don't know. I don't know what it's like. Is it the ones before? Yeah, because a car can only intersect if it's faster than the cars before it. No, I'm watching the video, guys. I'm sorry. I just have no idea what's going on. No idea.
Hey everyone, welcome back, and let's write some more Leetcode today. So today let's solve the problem car fleet. I think a lot of people don't end up solving this problem, but I think it's a very good problem and interesting problem to solve. So we're given n cars that are traveling along the same road. It has one lane. The road has only a single lane, and this is important for the rest of the problem. All the cars are traveling 5 cars, right? So initially we have fleets. Okay, so now let's try to figure out how we can actually solve this problem. Now let's take a look at our own example. So here you can see I'm basically combining the two arrays that they give us. I know they give us a separate array for position and speed, but I'm just going to combine it into an array of pairs. So this pair represents, the first is the position, next is the speed. So this is at position 3 with speed 3. This is at position 5 with speed 2. This is at position 7 with speed 1. And our target in this case is 10. So I'm going to actually explain this problem in a way that you might not expect, because when you actually think about what these cars are, they're literally just a system of linear equations. Right, we have the time on one axis and we have the position on another axis, right? And if we take a single example such as this one, right, it starts at position 3. So position 3 is over here on the chart and it has a speed of 3. What does the speed mean? It means that the slope is going to be 3, right? So every unit of time that passes, it will be in 3 positions ahead, right? So in 1 second, it'll be at position 6. In 2 seconds, it'll be at position 9. Excuse my kind of bad drawing here. And then at time 3, it'll be at position 12. So basically, it reaches the destination 10, right? Remember, 10 is our destination. It reaches it at, let's say, 2 point something seconds, right? And we could calculate that if we really want to pretty easily. It's just a linear equation, but I'm just drawing it out just so you kind of get an idea of what's going on here. So now let's do this one, 7, 1, and let's use a different color just to kind of illustrate things. So it starts at position 7 and it has a slope of 1. So each unit of time is just going to go up 1 position. So at time 3 is when it's going to reach the destination, right? So we can draw a line like this one. And what you can already tell from this drawing is these intersect here, right? They intersect before they reach the destination. What does that tell us? That tells us that they are going to become a car fleet. This orange one and the blue one, right? They intersected over here before the orange one reached the destination over here. So what's actually going to happen with this orange one, this part of the drawing is not going to happen, right? Because once they do intersect over here, the orange one is going to travel at the same speed as the blue one because it can't pass the blue one, right? On the drawing, we showed that the orange one passed the blue one, but that's impossible in the context of this problem, right? So a better drawing for the orange one would have been something like this. Right, like it starts at a high slope, but then it slows down. And just to finish up the drawing, so this other one, 5, 2, it starts at position 5. It has a slope of 2. So by the time it reaches the destination, it'll be at 2.5, which is about over here, I think. So let's just draw a continuous line. And even though it's kind of hard to draw a straight line here, but you can see again, these intersected as well, right? So that must mean, since all 3 of them intersected, that must mean that we're going to have a single car fleet, right? And that's pretty obvious when you look at a drawing. And actually, when we look closer at the drawing, we see that the orange one intersected with the green one before it intersects with the blue one. So actually, when the orange one intersects here, it's actually going to be traveling at the same rate as the green one. And you can continue with this drawing if it kind of gives you a good intuition of the problem. I just wanted to kind of show you like where I'm coming from with this problem and that I'm not just immediately jumping to the solution. But knowing kind of this idea, we can kind of get into the solution to this problem. And we can actually do it in linear time. So now you can see that I've drawn the cars and their positions in sorted order, and that makes sense, right? Wouldn't we want to go through the cars in sorted order? Because of course we know that they can't, like the relative order of the cars is never going to change. So it makes sense to go through them in sorted order. Now, for any 2 given cars such as these 2, how do we know if they're going to intersect or, they're going to collide and become a single car fleet before they reach the destination position? Well, basically by the drawing I showed you earlier, if these 2 intersect each other, right? So what we could do is actually calculate the intersection point of these 2 if we really wanted to. But there's a slightly easier way. We can just calculate what time is this car going to reach the destination and what time is this car going to reach the destination. If this car reaches the destination before or at the same time as this one, that must mean that they became a car fleet, right? They became a car fleet somewhere in the middle, somewhere in here. So since this one is moving at 1 mile per hour and this one is moving at 2 miles per hour or whatever, whatever unit of speed or something that they gave us, we can calculate what time they're going to reach the destination. We can do it pretty easily, right? we can just take the distance difference for, I'm going to do the green one first. We can take 10 minus 7, right? That's the distance that we need to travel, 3 units of distance, and divide that by the speed, in this case 1. So this is going to reach the destination at time equals 3. We can do the same thing for this one. So 10 minus 5 divided by 2, that's going to be 2.5. So this is going to reach the destination at time 2.5. So that must mean that they are going to collide. So we know they're going to be one car fleet. So technically we can kind of just like delete one of these, right? And just not consider it anymore. But which one of these two are we going to remove, right? Like, okay, let's say I remove one and then, I start comparing the remainder of the list that's on the left side. Well, I'll tell you right now, we're always going to keep the one that comes ahead, because if these collided, they're going to end up being reduced down to the speed of the one that's ahead, right? So this is going to start traveling at 1 instead of 2, right? That's going to be the new speed. So if we want to know if these two intersect, it's going to be harder to calculate because this one is going to have 2 different speeds.
Okay,
Initially, it's going to be 2, but at some point...
I need to do my laundry though. I'll be right back. Okay, we're back. So, okay, kind of lost my train of thought because I had to leave. Let's just rewatch the part of this video real quick.
And they're going to reach the destination.
No, I mean, you just calculate this one, you put it on the stack, and if this one is larger than this one, then you fucking don't put it on the stack. It's really simple. But you have to sort this array. So, okay, see, that's going to be like low-key the hardest part of this entire problem. Oops. So I want to have a vector pair of int p and then for int I equals 0, I less than position dot size I plus plus int car okay, and then p dot push underscore back car, and I just want to see if this like compiles. Oh, okay, so now we're gonna have a stack of double s and 4 oh no, we need to sort this. Okay, how to sort you're gonna do this? Okay, that's awesome. Sort p dot begin p dot end. Is that what that said? Yeah. Okay. Let's just for. Let's just make sure. For auto p or pair in p count pair dot first pair dot second, and let's just see if that does 0 1. Okay, nice. All right, I guess it should be car. Nah, it doesn't matter. So now we need to... Yeah, we need this stack here. Okay, so if stack dot empty or okay, we need the math thing. We need the double final dest equals target minus pair dot first divided. How do you do? How to? Is it called double division? You need to ensure that at least one of the types is a floating point. Okay. I think we should be good there then. I'm not going to worry about it for now, but... I'm not going to worry about that for now. So, or pair that. Let me just make sure that's the equation.
I'm going to travel. This is going to reach the destination.
10 minus...
So 10, the destination to collide. Like delete.
Yeah. Okay. Is less than stack dot top. I don't really know why it's a stack, to be honest. I don't know. Final dest is... Wait. Greater. Then you push it. Stack dot push final dest. And then return s dot size. And I'm realizing that this needs to be s. Oh, I need to do I need to go backwards? I need to go backwards. Or no, int I is p dot size minus 1. I is greater than or equal to 0, and I minus minus. And then we'll do auto pair is equal to p at spot I. I think that works. Nice. Okay. Bruh. Shit. Ten minus 8. Oh, it's doing the fucking... It's not doing... How do I know? Fucking genius. That's how. Yup. Well, let me submit without the print statement. Why am I so slow? There you go. Yes, sir. Nice. Okay. Yeah, so nice. We got that one done. Pretty simple. Let's do some learn CP Pizzle. Yeah? Oh. Now that is bright. Let me tell you. Bruh. Okay. That's funny. Okay. So guys, my goal is just to get through this really fast because I want to move on to like actual computer science topics. Like I'm kind of like, you know what I'm saying? Yeah, you know what I'm saying, guys. You know what I'm saying. You know what I'm saying. I didn't put a bookmark here. What, the Sigma? Okay, let's just go this one. The as if rule. Introduction to optimization. I'm taking that class next semester, Introduction to Optimization. Kind of nervous. Dude, I'm supposed to be taking Intro to Algorithms. I don't know why it's an intro class. It's just like the only algorithms class you take. But I'm on the wait list, dude. They need to get me off that shit. Okay. Here's the process. Oh, gosh. I know about this. That's cool. That makes sense. It's like I need to turn my heater on. It's cold as a beach. It's on. I turned it on. Okay. What was it? Constant folding? That's interesting. Hmm. The hell? Do you see this on my mouse? Oh, that's what it's doing. What the fuck? Ubuntu moment. Ubuntu. Oh my god. Is a runtime constant. Oh, that's what you mean. Okay, that makes sense. Or not all that useful. Did I swear that's what he always does that shit. What? Expressions evaluate at runtime, and in some cases they must do so. What kind of sentence is that? Oh, this is a. Is this meant to say compile time? What is constant expression? I'm writing that down. Constipate. EXPR must be evaluatable. Bruh. But can I do that? No. Okay. Or maybe you know what I'll do? to safety. And this is like a lot of reading. Wait. Oh, and now it's time to get my laundry.